So we are now going to do some calculations with regards to how fast these gas molecules are moving. We've done calculations with about their pressure, their temperature, their volume, their moles of gas, about how much is present. How fast are these molecules going? Well, if we were to take a sample of a particular gas molecule at a particular temperature, we would find that sample of molecules that there's actually a varying amount of speeds present. But you'd see sort of like this oddly shaped bell curve. And it turns out that what is easily calculated from this bell curve is something called the root mean square speed of a particular sample. So you can imagine that when calculating the speed of a gaseous sample, that this curve is going to be, and particularly the root mean square speed, that is going to be temperature dependent. And in fact, it is. If you were to take that same curve and that same sample and heat it up, you would see the curve shift, and you would see that the amount of gas molecules that move at a particular speed increases. So you should know that molecular speed is dependent upon temperature. You should be familiar with how that affects this curve, and you should also know how to do calculations to determine the root mean square speed of a pure sample of gas. That equation is the square root of 3RT divided by M. Fairly simple equation, but make sure that you use values in the appropriate units. We are now going to use R, which is still the gas constant. We are now going to use R in terms of joules per mole Kelvin. Since R is in joules per mole Kelvin, obviously temperature has to be in Kelvin, our mass, specifically our molar mass, for our units to cancel appropriately, needs to be in not grams per mole, but kilograms per mole, because of how the units work for joules. And so using a gas constant in joules per mole Kelvin, a temperature in Kelvin, and a molar mass in kilograms per mole, that gives a root mean square speed with units of meters per second. So in the next slide, we're going to go ahead and do an example. What if I was to ask for the speed of a sample of molecules, specifically of nitrogen molecules at 25 degrees Celsius? Using the equation, and after converting the temperature to Kelvin, my molar mass, well, I know my molar mass of N2 is 28.02 grams per mole on the periodic table. Convert it to kilograms, 1,000 grams in a kilogram. After making those conversions and setting up the equation and putting in the appropriate values, you get an answer that is 515 meters per second. So you should know what affects the RMS speed of molecules, molar mass and temperature, and you should be able to calculate it given the appropriate information.